So today we're going to learn about another statistical device that we can use to kind of make comparisons between two sets of data, like the scatter plot. But this time we're going to use what's called a two-way table, and we're going to learn how to construct, how to make them, and then how to analyze them. And we're going to start in your book on page 689, and it's going to start with an example that has what's called a Venn diagram. And you might remember these, from elementary school. So basically, let's just kind of look at this, and then I'll explain this Venn diagram down here. Venn is the name, VENN. So let's say student athletes, the data from a survey of 440 students are shown in the table. And the students were asked whether or not they were on the honor roll and whether or not they played a sport. So there's our two things that we're looking at. In the table, only on the honor roll, there were 115 of those 404 total students were only on the honor roll. 45 only played a sport, and then played a sport or on the honor roll were 250. So in a Venn diagram, the people that are only on the honor roll, and that means not doing a sport, they're going to be in the honor roll bubble, but they won't be in this intersection area where the two bubbles, those two ovals overlap. Those folks, that number of students, are the kiddos that were on the honor roll and did a sport. So that 115 that was only on the honor roll are right there. And the 45 that only played a sport are on that piece of the sport bubble that's not both. And those that played a sport and are the honor roll is the overlap, or what's called the intersection of those. Now, if you add those three numbers up, you will see that that doesn't account for all 440. So if you take the 115 plus the 250 plus the 45, you're only going to see 410 students. And you're like, well, wait a minute, where did the other 30 go? And they are the kiddos that are not on a sport or the honor roll. They're not included on being on the honor roll only, the sport only, or both. So those are the 30 kids. So they're sitting outside here because they don't belong in one of those three spaces. So let me just get used to a term before we switch this over to a table. We're going to make this Venn diagram a two-way table in a second. But a relative frequency is the ratio, and that would be, numerator to denominator. Think of a fraction of the value of a part subtotal to a total. Think of a fraction, part over whole. And that's kind of what a relative frequency is you're going to take part over the whole. So let's look here. What is the relative frequency of a student that is on the honor roll and plays a sport? So all the students that are on the honor roll. So the top, the numerator, is the number of students on the honor roll and plays the sport. And do you see that's 250? To all the students that are on the honor roll. Now, who are all the students on the honor roll? It's everybody in the honor roll bubble. So if I take 115 plus 250, I'll get 365. So part over whole. The top is the kiddos that did both, and the bottom is the total kiddos that were on the honor roll. These two added together, right? So now, if you were to take the 250 divided by 360, that'll give you the decimal, and then you can change that to a percent. So if we take 250 divided by 365, it's about 0.68. And to make that a percent, you multiply by 100, you move the decimal 2 places to the right. That was our first unit of the year. It's 68%. So the question is there evidence that students that play sports are also on the honor roll? And what we just did was say that about 68% is more than half of the students of the honor roll play a sport. So that 250 that are, are play a sport and are on the honor roll are 68% of the total population of kiddos on the honor roll. So it does show that there's a correlation, a connection between playing a sport and being on the honor roll. So what we're going to do is we're going to take that same information and we're going to construct what our topic is today, which is a two-way table. In two-way, I want you to think of columns. Now, columns go down. So down would be a column, and rows which go across. So a two-way table shows data from one sample group as it relates to two different categories. So the two categories, this is the exact same data we just looked at, but on a two-way table. So everything in this column has to do with playing a sport. Everything in this column has to not play a sport. And down here, everything in this row is being on the honor roll. And everything on the second roll is not on the honor roll. And basically, as you look at the bottom of each column, that is a total of play a sport. This is a total of don't play a sport. Over here, this is a total of on the honor roll, and this is a total of not on the honor roll. And I call this the total. This is the total, the grand total, have you may, okay? So to get a total, bottom of the column, you just have to add these two. To get this one, you have to add these two, and the row the same thing. And if one's missing, sometimes you have to do a subtraction. So I'm just going to go back and I'm going to remind you of, see these four numbers that are sort of circled or ovaled here? They're the ones that were present on the Venn diagram. Oops, there we go. So 115 only on the honor roll, 45 only taking a sport, and 250 was both. So if you come over here, there are on the honor roll and play a sport. There's the intersection, the 250. Here's the 45 that play a sport but aren't on the honor roll. And there's the 115 that don't play a sport but are on the honor roll. And each one of these is called like a cell. And it has two things that are, adding up to it, or two things that you're looking at to determine what number goes there. Now, the other number they gave us was what I call that total, the grand total. They told us there were 440 total students. So I filled those in the appropriate cells of the table. And the next thing I'm going to look at is, I know that this number is easy to find by adding 250 and 45. That's the total number of students that play a sport. And then up here, if I went this way, that's the total number of students on the honor roll. Right? So once I have those numbers, these two are easy to get, because if I take, this plus this one had to equal 440. So you can always take and kind of do the opposite. Take 440 minus 295 would have given me the 145. And 440 minus the 365 would give me the 75. And now this one's easy to come by. You can take 75 minus the 450 to get 30, because in the end, these two have to add up to 75, and these two have to add up to 440, and so forth. So if you've got the two that add up to that total, you just add them. But if one of them's missing, you take the total minus the one you have to get the one that's missing. And then you can use this to answer all kinds of questions rather. We'll get there in a second. So let's do this next one. But Philippe surveyed students at his school, and he found that 78 students own a cell phone, period. It only talked about cell phone. So what we got here going is we've got a cell phone row and an MP3 player. That's like just a music device, not a cell phone, but it just plays music, okay? So that's what the two things are. There's a row that is cell phone, and there is a row that is the music player. So when it says that he found 78 students own a cell phone, period, that's your cell phone total. It didn't say anything about an MP3 player, so that's your cell phone total. 57 of those students, so 57 of the 78 own an MP3 player as well. So there's the 57 that have the cell phone and the MP3 player. There are 13 students that do not own a cell phone, but they do own an MP3 player. So you come down to the no cell phone and you look at, but they do have an MP3 player, and right here is where they would go. Now notice when we set up the table, I should have mentioned this, that you always will put cell phone and then the opposite of that in the same sort of, so they would both be a row. You wouldn't put MP3 player and cell phone next to it. I should have said that before, but when you construct it, you have to have the thing that you're looking at and like its opposite. So having it, not having it, having it, not having it in the same either row configuration or column. All right, back to this one, there's one more piece here. 9 students don't own either. So that's no cell phone, no MP3 player. There's your no cell phone row. There's your no MP3 player, and there's where the 9 go. With those 4 numbers, we are able to fill in the rest of the table. So this is the total for the MP3 player, so we could just add those 2. This over here is the total for the no cell phone. We could just add those 2 numbers, 13 and 9, and get it. And then we're able to fill the table from there. Let me show you the filled in table. So, 57 plus 13 is 70. And 13 plus 9 is 22. And then if I take 78 plus 22, that's 100. Remember we had this 70, so what number plus 70 equals 100? Well, you can take 100 minus 70 and get 30, and these 2 should add to 100. And now there's kind of all kinds of choices to kind of get some of the other ones, but to get this right here, if I look at this row, this and this have to add to 78. So if you take 78, the total minus the 57, that'll give you 21. And then I would have had the 21 and the 9, and I can add to 30. So you can actually fill out the whole table just by having those original 4 numbers. So let's see if you can do one. So you're going to take this, and what this is there is 150 children at summer camp. 71 signed up for swimming. There were a total of 62 children that signed up for canoeing, and 28 of them, 28 of the 62, also signed up for swimming. Construct a two-way table summarizing the data. So the 2 things we're looking at is swimming and canoeing. So swimming, I'm going to put as rows, and canoeing, I'm going to put as columns. So swimming would be a row, and then its opposite, no swimming, would be the row below. Canoeing would be a column, and no canoeing would be the other column. Let's start right now by simply placing those 4 numbers that they gave us in the table. We're going to stop the video and give you a chance to do that. So let's start with the 150 children. That is what I like to call your grand total. Okay, so there's 150 kids, period. It didn't say anything about swimming. It didn't say anything about canoeing. It's your 150 total. 71 signed up for swimming. So I find the swimming row. It said nothing about canoeing. That 71 is my total of my swimming population. There were a total of 62 children that signed up for canoeing. 62 signed up for canoeing. Here's my canoeing. And right there, that if we ended that statement that says nothing about swimming, there's my 62 that signed up for canoeing. And 28 of these 62 also signed up for swimming. So here is your swimming, canoeing, and there are your 28. So, that first part is important that you read carefully and think about where they go. And now you could fill in the rest of the table. So we're going to stop and let you do that. And I just wanted to make sure you had it fixed before we did the next part. So there are different ways to go about it. But right now, I see that I could get this number for no swimming because 28 plus whatever that has to equal 62. I pick up my calculator. 62 minus 28 would give me 34. And now if I add the swimming and the no swimming, it would total 62. I could do the same thing over here and take 71 minus 28. So the canoeing plus the no canoeing, which would be 43, has to equal 71. Again, we've got a couple choices here, but the canoeing plus the no canoeing has to equal 150, that total. So if I take the 150 minus the 62, that'll give me the no canoeing total. Again, you have a choice here. I'm going to go over to the total over here, and if I take the total minus the swimming, that'll give me who didn't swim, and that would be 79. And there's a lot of different choices here, but if I look at no swimming, there are 79 total kids who did not swim. And if I take away the 34 that did canoe, that'll give me the no canoeing, no swimming kiddos. And that was 45. And I don't know, were they sitting on a bench just watching people? I don't know. And there is my two-way table. So what do we use the two-way table for? So we're going to go back to that idea of a relative frequency. We're going to go back to that idea of a percent, like what percent of kids are doing things. And we can use the information on a table to do that. So this two-way table goes back to the one we did with the cell phone and the music player. It's the same data a few slides back. And now they're going to take that data and they're going to find the relative frequencies by row. And notice I put, I circled that. Looks more like an oval, but I circled that because I need to get my eye on looking at rows, not columns. Okay, so to find the relative frequencies by row, you're going to write a ratio, part on top of total. That's what a fraction is, part on top of total. And you're basically going to see, here's your total on the row. We're only looking at rows. And if I take 57, the part, that is MP3, over the total, and 57 divided by 78 gives me 0.73. Now I move over here and I'm going to take 21 divided by the row total, and I'm going to get 0.27. I'm going to drop down to the no cell phone, and I'm going to take 13 over that total 22, and it's about 0.59. And 9 over the 22 is about 0.41. We really don't talk about the relative, well, you'll see them out here, but 78 over 78 would be 100%. So they're really looking for this main body of the table, not the total rows, to do relative frequencies. But basically what that allows you to say is 0.73 is 73% of the kids that you can look at that had a cell phone, and 27% didn't have an MP3 player. So 73% of the kids that had a cell phone also had an MP3 player, and 27% of the kids that had a cell phone also did not have an MP3 player. So we're looking at just from the perspective of having a cell phone. And then if you didn't have a cell phone, 59% of the kids had an MP3 player that had no cell phone, and so forth. And that's how we kind of can look at that. So based on the relative frequency value of 0.73 in one of the cells, you can imply that most students that own a cell phone also own an MP3 player. So 73% of the kids that have a cell phone also own an MP3 player. So this is that same exact two-way table, but this time you're now going to do it by column. So you're going to take the kids that have a cell phone and an MP3 player, and you're now going to talk about that as part of the total that have MP3 players. So numerator over denominator. Can you fill out this table, please, finding the relative frequency by column? So this guy would be 57 over 70. And this guy would be 13 over 70. I pick up my calculator, top divided by the bottom, it's about 0.81. Top divided by the bottom, it's about 0.19. And again, 70 over 70 is your 100%. And then if I take 21 over 30, it's about 70%. 9 over 30, it's about 30%. And 30 over 30 is 100%. So now we're talking about, of the kids who own a music player, a MP3 player, 81% of those kids also own a cell phone. And of the kids that own an MP3 player, 19% do not own a cell phone. And we could do the same thing here with that column. So you can look at it at the perspective by row, or you can look at it the perspective by column. Two more quick problems here on two-way tables. Eloise surveyed the students in her cafeteria and found that 38 biological males agreed with the new cafeteria rules, while 70 do not. There were 92 biological females surveyed, and 41 of them agree with the new cafeteria rules. Construct a two-way table summarizing the data. Can you put the four numbers into this problem? The 38 males who agree would be males and agree, so that would be where the 38 went. And the 70 males that do not would go in that cell. 92 females, period. Just 92 total females would go out in the total row, total. And 41 of those 92 agree. At this point in time, you should be able to fill out the rest. If you need to go back and fix, take a moment to do that. The total for agree with the rules, 38 plus 41. The total biological males would be 108. The total, 108 plus 92 would be 200. 200 minus 79 would give me the total that do not agree. And 192 minus 70 would give me the 51 females that do not agree. Let's talk about that relative frequency and give you a chance to practice by row. This table shows 7th and 8th grader, whether they get their news from TV or the news from internet. And we're going by row. Can you put the relative frequencies in by row? So the first thing we need are the totals. So 7th grade total would be 62 for that row, and 8th graders would be 88, adding the two numbers to get that. And now we take part over total, 13 over 62. 13 divided by 62 would be 0.21, 21%. 49 divided by 62 would be 0.79, and 62 divided by 62 is 100. 20 divided by 88 would be 23%, or 0.23. 68 divided by 88 is 0.77, and 88 divided by 80 is 100. I'm not sure why they put the row total down here. It would be 13 plus 20. I don't know if it was just one of those to confuse you. 49 plus 68 and 62, the total students would be the 150. And they're just asking you, what do you notice? And what I notice right away, look at these numbers. Both of these are over like 3/4. Over 75% of both 7th and 8th graders are using the internet. So if you're a person that's advertising, trying to buy advertising space for that age group, you're not going to look at TV news, basically. So over 75% of the 7th and 8th graders get their news from the internet. So that's how a two-way table relates. Two different sets of data. We learned how to construct them. And with 4 strategically placed pieces of data in there, we can fill out the whole table. And then we talked about, how do we use that by constructing percents, relative frequencies, and you have a choice. You can look at it, like in this case, the perspective grade, or you can look at it the perspective of the type of media. Next time I see you, we'll do some more practicing with two-way tables. Until then, have a great day.